So we continue with the current electricity and we are in the part B of the chapter, that is potential difference and resistance. Now potential difference, so basically we are talking about the potential of 2 points of a circuit. What do you mean by potential? Potential is basically the capacity or the, you can say, capacity to have the work done or the energy present in that. So we will find that in case of a electrical circuit also, the potential will be dependent upon the number of electrons and the number of protons present in that particular thing. So if I see that there are positively charged, so if I have got two conductors, suppose I have got two conductors, one conductor here A and one conductor B over here. Now if this is positively charged, okay, this is positively charged, and if I connect this to a wire to this B, it will be seen that because this is positive charge, the electrons are going to move from here to here. So this is the flow of electrons. So electrons are going to move from B to A. So this is positively charged conductor and this is an uncharged conductor. Even if it is uncharged or negative charge, the electrons are going to flow from here. So because this is uncharged also, even if it is uncharged, the electrons are going to flow from here to here because this is positively charged. So they are attracting the electrons towards itself. Same way, if this would have been negatively charged and this would be connected to another B over here, which is again uncharged, then the electrons are going to flow from here to here. The electrons are going to flow from this point to this point, right? And now if I am going to have it this way, that this is A and this is B, such that this is negative charge and this is positive charge, you will find that the one connecting over here, the electrons are going to flow from here to here. So the electrons are going to flow over here from A to B, in this case also when it is uncharged, and this case also when it is fully charged. So you will find that the flow of electrons, it is whether I have got positive more or negative more, the flow of electrons is the cause of the flow of current. The current is going to flow not because of any movement of the protons. Protons are not going to move at all. The positive charge does not move. It is only the negative charge which moves from one point to another point. So that's why the flow of the current, the flow of the electrons is going to be there from higher number of electrons to lower number of electrons. So this is lower electrons, this is higher electrons, so here to here. More electrons, less electrons from here to here. More electrons, less electrons from here to here. So let's see the explanation. Flow of electrons between conductors. When two charged conductors are joined by a metallic wire or they are placed in contact, free electrons flow from a conductor having higher concentration of electrons to the conductor of having lower concentration of electrons. So always it will be the flow of electrons moving from higher concentration of electrons to lower concentration of electrons. The movement of electrons stops when the concentration of electrons in both becomes equal. This can be understood by the following example. So yes, if we are going to connect them, it will keep on flowing till the number of electrons over here and the number of electrons over here is going to become equal. Till the time it is going to keep on flowing from higher potential, that is higher number of electrons, to lower number of electrons. Example 1, in figure 9.18, a positively charged conductor A is connected to a metal wire and to an uncharged conductor B. Electrons move from the uncharged conductor B to the charged conductor A to balance the deficit of the electrons in the conductor A. This movement of electrons will continue till both the conductors have equal concentration of electrons. So in this case, till the time iske number of electrons and iske number of electrons do not become equal, the flow of electrons from B to A will keep on taking place. In the second case, In figure 9.19, a negatively charged conductor A is connected to a metal wire to a uncharged conductor B. Electrons flow from the charged conductor A, which has excess of electrons, to the uncharged conductor B, which is neutral. This movement of electrons stops when both the conductors acquire equal concentration of electrons. So here also it's going to be this way. The electrons over here are going to move towards B, and they will keep on moving from A to B till the time the concentration of A and B does not become equal. The number of electrons in A and B does not become equal. In the third figure, in figure 9.20, two uncharged conductors A and B are joined by a metal wire. The conductor A is negatively charged while the conductor B is positively charged. Electrons flow from the negative charged conductor A, which has excess of electrons, to the positive charged conductor B, which has deficit of electrons. This flow of electrons continue till there is equal concentration of electrons in both the conductors. So again the same thing, that electrons over here are more, electrons over here are less. So electrons from here move towards B, and it will keep on moving unless and until the number of electrons over here and number of electrons over here become equal. So what do you infer with this thing? From above examples, it is clear that the flow of electrons between two conductors joined by a metal wire can be maintained for a long time if it is somehow made possible to maintain an excess of electrons in one conductor and a deficit of electrons in another conductor. This is done by electric cell. So we can infer that there is going to be a flow of current over here, here and here. Why is there flow of current? Because of the difference in the number of electrons in A and B. If the number of electrons in A and B are going to be equal, then there will be no flow of electrons. So for a flow of electrons to be possible, there has to be some kind of a difference in the number of electrons in both these conductors. So if we are able to keep on maintaining a particular difference in the two ends A and B over here, then the flow of current will be continuously possible. So if by some means, if I keep on adding positive charge to this thing, so that the electrons from this keep on coming, in that case the current will be flowing continuously. Same thing got there also. If I keep on giving electrons to this, so that the difference is maintained, and hence the flow of current will be possible. This exactly is done in a cell. In a cell, the electrolyte is giving that extra electrons. Okay, the cell is maintaining the difference of the electrons in both the terminals of the battery, so that the flow of electrons is continued. In an electric cell, an excess of electrons on one electrode, that cathode, and a deficit of electrode on the other electrode, anode, are maintained and for a sufficiently long time by a chemical reaction within the cell. So they are, by a chemical reaction, the number of electrons in the, on one side, on the cathode side, the number of electrons in the cathode, and a deficit in the anode side is maintained by the chemical reaction. And due to this chemical reaction, maintaining the chemical reaction के कारण क्या होगा? There will be a flow of current taking place for a longer period of time. Thus, an electric cell works as a source of electrons. There is a continuous flow of electrons in the external circuit connected with the cell in direction of the cathode to anode. So that is how the cell works. And now see, let's the direction of the electric current and conventional and the electronic flow. So we learned earlier that the electronic flow was the one wherein the electrons are going to flow from higher number of electrons to lower number of electrons. So one which has got more number of electrons, from there the electrons are going to move from higher level to lower level. But what is the current? Conventional current is opposite of that. So let's see the same thing. It is a common experience that if a body is released from a height, the body always moves from a higher level A away from the earth to the lower level B near the earth's surface. That is, from a higher gravitation potential to a lower gravitation potential. So we always see that every physical quantity is going to be move, or any object is going to move from a higher level to lower level. Water, एक जगह पे ज़्यादा पानी है, जिसमें कम है, तो automatically it flows from here to here. Anything falling, it goes from a higher level to lower level. Water falls from a higher level to lower level. Electricity also accordingly will flow from higher level to lower level. So similarly, if two vessels containing water of up to a different level are joined together, water flows from level A, vessel A containing water up to a higher level, to a vessel B containing water up to a lower level. This flow of water is due to the difference in the hydrostatic pressure or level of water in the two vessels, and it continues till the level of water is same in both the vessels. So we see that till the time both of them have not reached an equilibrium, the flow of water is going to take place. The same thing is also for temperature. Temperature also, you find that if there is one body which is high temperature, other having lower temperature, then when you are connecting these two, the higher temperature will lose its temperature and give it to this, so that they both become balanced. So if this is 20 degrees Celsius, this is 30 degrees Celsius, ये दोनों साथ में आएंगे तो both will be at 25 degrees Celsius. We have also read that if two bodies of different temperatures are kept in contact, heat flows by conduction from the body A at a higher temperature to a body B at lower temperature, till both the bodies acquire the same temperature. In a similar manner, when two charged conductors are joined by a wire, the direction of flow of electrons is determined by the quantity called the electric potential of the conductor. So let me take this example over here. So you can see that this is positive charge, this is negative charge. So the flow of the current is going to be determined by the potential which is present between the two conductors. So a conductor having an excess of electrons is said to be at negative or lower potential. Now we always consider that negative is lower. That's why the electrons जहाँ पे ज़्यादा है, भले वो ज़्यादा है, फिर भी electrons are considered to be at lower potential. Okay, so more number of electrons. If any particular conductor has got more number of electrons, it is at lower potential, and the one which has got less number of electrons is at higher potential. So let's see once again this particular thing in a different manner. So we have over here this particular kind of a substance A, which is at negative, that has got too many electrons over here. So this is the one over here, which is higher number of electrons. Okay, and on the other hand you have over here, so okay, we'll take what is there in the textbook. So we will take this way as positive. So this is at lower number of electrons, and hence higher potential because of positive charge. Because it is positive charge over here, it's a higher potential. This is a body which is B, which is having negative charge over here, and because it has got electrons over here, so this one is higher number of electrons, but in a way it is at low potential because it is negative charge. Because it is negative charge, so it is at low potential. So when these two are connected together by a wire, you will find that the electrons will move. So these electrons are going to move from here to here. So electrons are going to move from B to A. Okay, electrons are going to move from B to A, but the current is going to move from A to B. This is the current. So current is going to move from A to B because current moves from higher potential to lower potential, where electron moves from higher number of electrons to lower number of electrons. So these are the electrons and this is the current, I. Okay, in figure 9.24, a positively charged conductor A has a deficit of electrons, that is at high potential, is joined to a metal wire by a negative charged conductor B having a less number of electrons at low potential. The direction of the flow of electron is from the conductor B to conductor A, that is from low potential to high potential, in keeping with the convention of the flow from a higher level to lower level. See, we want to keep it in the convention that everything flows from higher level to lower level. इसीलिए हम लोग ने क्या किया? Flow of current we are considered as from positive to negative, that is from higher potential to lower potential. So in keeping the convention of the flow from a higher level to lower level, the electric current is said to flow from a body at higher potential to a body at lower potential, that is in direction opposite to the direction of the flow of electrons. Thus, the direction of flow of conventional current is opposite to the direction of the flow of electrons. So, you can see over a star at the bottom, that is heat flows from a body at a higher temperature to a body at lower temperature. Liquid flows from a higher level to lower level. So we say that current flows from higher potential to low potential. See, we don't want to break that particular kind of rhythm that okay, everything moves from higher potential to lower potential. So वो higher level to lower level. तो इसलिए वो maintain करने के लिए we consider the current to be flowing from higher potential to lower potential, which is opposite to the flow of electrons. Elementary idea about work done in transferring charge through a conducting wire, that is potential difference. So now we talk about potential difference. We know that like charges repel and unlike charges attract. Therefore, to create an excess or deficit of electrons at one point, some work is to be done in moving the charge against the force between them. So if I want to move a charge from here to here or from here to here, I know that either it will be that they are like charges, so they are going to repel, or they are unlike charges, so they are going to attract. So accordingly, we need to do some work in moving the charge or electrons against the force between them. So there will be either a force between them which will be attractive, तो उसको हम लोग को repel कर बाहर लेके जाना है तो हम लोग उसके against काम करेंगे, या तो if it is a repelling force then we are trying to bring it near, so it will be the force which will be work done in opposite to the work done by the repelling force. The force between the two charges is zero when they are in infinite separation. Hence, quantitatively, the potential at a point is measured in terms of work done in bringing a charge Q from infinity to that point. If work W1 is done in bringing a charge Q from infinity to a point, then the potential at that point is V is equal to W dash upon Q. So, let's see this. Now, this is quite important to understand. Now, when we talk about, suppose this is one particular charge, so this is a charge Q which is to be brought to this particular point A. So, when this charge Q is going to be brought to this point A, so this is at infinite distance, so this distance is infinity. So, when the work is done for bringing this charge from here to here, so the amount of work done in bringing a charge from here at infinity to this point over here is called as the potential of A. This is potential of A. So what is potential of A? That is potential of A, that is V is equal to work done upon the charge. So it is work done, that is W dash upon the charge which is Q. Okay, potential is nothing but work upon charge, because the potential is what? We know what is potential. It is the capacity to do work. To do work on what? It is to do work on the charge. So work done on the charge. So that's why V is equal to W upon Q. Now potential is a scalar quantity. Its SI unit is joule per coulomb. So you know over here this is nothing but work is done in joule and the one is in coulomb. So joule per coulomb. So J per coulomb will be the SI unit over here, which is given as equal to 1 volt. Okay, this is 1 volt or capital V. Okay, that is 1 volt. So the SI unit is joule per coulomb or volt, symbol V. Similarly, the potential between two conductors is measured in terms of work done in transferring the charge from one conductor to the other through a metallic wire. So now if I have got another thing over here which is B, and the work done will be like this from here to here, suppose this is W2. So automatically क्या हो गया? यहाँ से लेकर यहाँ तक का वर्क कितना होगा? This will be equal to W1 minus W2. So we can see that this is the potential difference. This is the potential difference between A and B. यानी infinity से यहाँ तक लाने के लिए और infinity से यहाँ तक लाने के जो work done है उन दो का difference is nothing but the potential difference between A and B. So we see that the potential difference between two conductors is equal to the work done in transferring a unit positive charge from one conductor to another conductor. So from one conductor to another conductor, whatever is the work done in moving a unit positive charge from B to A is called as the potential difference between the two conductors. If work done W is given in the transferring a test charge Q of one conductor to the other, the potential difference between them will be equal to V1 minus V2 is equals to W upon Q. Potential difference is a scalar quantity. Units of potential difference from relation V is equals to W upon Q. Potential difference is W is in joule, unit of work upon unit of joule. The SI unit of work is joule and that of charge is coulomb. So the potential difference is measured in joule per coulomb, which is named as volt, abbreviation V. Thus 1 volt is equal to 1 joule upon 1 coulomb, or 1 V is equal to 1 J upon 1 C. So potential difference between the 2 points is said to be 1 volt. Now this is the definition of 1 volt, very important. So what is potential of 1 volt? We can define 1 volt as the potential difference between the 2 points is said to be 1 volt when a work done in transferring 1 coulomb of charge from one point to another is 1 joule. Okay, so that is 1 volt potential difference. So this is the concept of potential difference, that is the voltage between the two conductors. So first we say that यहाँ से लेकर यहाँ पे, suppose I say that from here to here the total amount of work done is required is 10 joule, and from here to here the total required is 7 joule. Then the work done from here to here is what? 10 minus 7 is 3. So that's why 3 is the potential difference between A and B. So potential difference between 2 points is the work done in bringing a unit positive charge from B to A or A to B, whatever it is, depending upon which is at a high potential. So that was about the potential difference. We now move on to the electrical resistance. Now when current flows through a metallic wire, it offers obstruction called resistance to the flow of current through it. Thus we define resistance as below. The obstruction to offer to the flow of current by the wire is called its electrical resistance. See, we very well know that when a current is going to flow, that the electrons are going to move from one end to another end, they cannot directly travel so easily. There will be some kind of obstructions for their movement. So the movement के लिए जो obstructions जो होते हैं, the extra obstructions which are going to be present for the free movement of the electrons from one end to another end of a conductor is called as resistance. So obstruction offered to the flow of current is called as resistance. What is the cause of resistance? A metal wire has free electrons which move in a random manner in absence of any cells connected together or across it. When the ends of the wire are connected to a cell, the current electrons start moving from the negative terminal to the cell to the positive terminal through the metal wire. During that movement, they collide with the fixed positive ions and other the free electrons of the wire, due to which their speed decreases and the direction of the motion changes. After each collision, they again accelerate towards the positive terminal and suffer collision with the other positive ion and free electrons. This process continues. As a result, the electrons do not move in bulk with an increasing speed, but they drift towards the positive terminal. Thus, the wire offers some resistance to the flow of electrons or current through it. Figure 9.25b shows the drift of the electrons in the wire. The electrons are shown in red dots, whereas the positive ions are shown as plus. So that's what they are showing over here, that we very well know that the metal, okay, the conductor is going to be made up of atoms. What does the atom contain? The atom contains protons and electrons. Both protons, positive charge, electrons over there, negative charge. The free electrons are the ones which are responsible for the flow of electron from one end of the conductor to the other end. So suppose this is the metal conductor. So from one end of the conductor to the other end of the conductor, the electrons का movement जो है, that is the cause of the flow of current. In between there will be protons and electrons which are there. So normally all the electrons are going to be in random motion inside the metal. But when they are connected to a battery, then what is going to happen? One is going to keep on giving electrons, another one is going to keep on dragging that. So that's why the electron का है movement यहाँ से लेकर यहाँ तक का easily होने वाला है, because there is an accelerated motion. The motion is going to be there for the pushing force which is going to make the electrons flow in one direction. So while they are moving, they are going to come across protons which are going to attract the electrons towards itself, and hence there will be an obstruction for the flow of electrons. So electrons will be colliding with them and they will not be able to go further very easily, and then they'll need to deflect a bit. Similarly, there will be electrons, other electrons which are there. Those electrons which are not connected in the free movement of the electrons over here, तो वो electron क्या करेगा? उसको deflect करेगा, because repulsion होगा दोनों के बीच में, and hence they will not allow. So that's why when the current is connected over here, when the battery is connected over here, there is not a bulk of electrons just moving from here to here. They are going to be in small quantities, like drift. धीरे 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 आगे जाएगा. So this drift is because of the resistance. That is the resistance, that is the obstruction offered by the protons and the electrons present inside the conductor. So that's why this is how we see that how the resistance is being developed in a particular conductor. The next is Ohm's law. According to Ohm's law, if a resistance, a current I flows through the wire, when potential difference through the ends of the wire is V, the resistance offered by the wire to the flow of current is the ratio of potential difference across it to the current flowing in it. So Ohm's law is a law which is given by one scientist over here, physicist, that is Ohm, and it states that current flowing through the conductor is directly proportional to the potential difference applied across its ends, only if its temperature conditions are remaining constant. So that's why we have over here that for any circuit, it is seen that the current and voltage, they are going to be proportional to each other. So it is seen that V is proportional to I, and because of proportionality remove करने क्या करेंगे हम लोग? We will say V upon I is going to be constant, and this constant is nothing but the resistance. So resistance is V upon I. This is the Ohm's law. This is Ohm's law. So as per the Ohm's law, the ratio of the voltage to the current of a circuit is giving the resistance of that circuit. So resistance is nothing but the ratio of the voltage, that is the potential difference, and the current passing through it. So potential difference is V and current is I. So R is equal to V upon I, or V is equal to I into R. Resistance is again a scalar quantity because it's not dependent on any direction. So the unit of resistance will be very simple. You know that the unit of this is voltage and this is ampere. So it is volt per ampere, or it is equal to ohm, that is omega. Okay, it's Ohm's law के लिए ohm or omega, which is the symbol of the resistance का units. The unit of resistance for the relationship R is equal to V upon I. Unit of resistance is unit of potential difference upon unit of current. So the SI unit of potential difference is volt V and the current is ampere A. Hence SI unit of resistance is volt per ampere, which is named as ohm, symbol omega. Thus 1 ohm is equal to 1 volt upon 1 ampere, or 1 omega is equal to 1 V upon 1 A. So we can define 1 ohm as the resistance of the conductor is said to be 1 ohm if the current of 1 ampere flows through it when the potential difference across its end is 1 volt. So if the potential difference is 1 volt and the current is 1 ampere, then the resistance of the wire is 1 ohm. This was about the resistance. Now we talk about the factors affecting the resistance of the conductor, but I'll take it in the next video.